This is lesson 3.6 day 1, proving angle relationships. So similarly to our last lesson, we now are going to look at angle addition. And so if we were to take our left angle plus our right angle, it would add up to the total angle. So for example, here we have ABD as 110 degrees, and then we have DBC as 35 degrees. So then ABC would end up being 145 degrees because we would add the left plus the right to get the whole. We have, they call it the supplements theorem. I'm going to go ahead and have you use the linear pair theorem or definition of a linear pair. Just because that's what most of my previous stuff is got as a reason from our former book. And then same thing with our complement theorem, just using definition of complementary. Kind of keeping things consistent with that. So we're going to go ahead and use our angle addition postulate. So the measure of angle 1 plus the measure of angle 2 is going to equal the measure of angle JKL. So that would be the angle addition postulate if you want to use the abbreviation AAP for angle addition postulate, that's fine. Then we're going to use substitution. So the measure of angle 1 plus the measure, not measure of angle 2, because measure of angle 2 is 56. So there's our substitution. We also can substitute 145 in for the measure of angle JKL. And now we can go ahead and use subtraction. So the measure of angle 1 is equal to 89 after we use our subtraction property and degrees. Looking at this next one, we're going to go ahead and put the reasons next to it. So this one, we have a definition of complementary. And then we have the substitution. And then we have subtraction. So reflexive, symmetric, and transitive, again working with congruence and equals. Vertical angles, theorem or definition, those are congruent to each other. And using our congruent supplements theorem and congruent complements theorem. So what that basically says is if they are supplementary to the same angle, then those angles are congruent. And we're going to use those here in just a little bit. Same thing with complementary. If they are complementary to the same angle, so if we see 4 and 5 and then 5 and 6, then we know that 4 and 6 would have to be congruent to each other if they are complementary or supplementary to each other. So here's a vertical angles example. We know that 1 and 3 are vertical angles. They are formed by intersecting lines. If I could spell, intersecting lines. So then angle 1 and angle 2 form a linear pair. And angle 2 and 3 are also formed by a linear pair. So since angles 1 and 2 are supplementary and angles 2 and 3 are supplementary, then 1 and 3 would have to be congruent by those congruent supplements theorem. Since they are supplementary to the same angle, angle 2, they are congruent. Looking at this example here, we have that 1 and 2 form a linear pair. Angles 3 and 4 also form a linear pair by the linear pair theorem or definition of linear pair. Angles 1 and 2 are supplementary, and 3 and 4 are supplementary. With that given, then 1 and 4 are congruent. So 2 and 3 by the congruent supplements theorem. Again, if they are supplementary to the same angle, which they are, then they are congruent. Looking down here at our example 5 with vertical angles, we have the definition of an angle bisector. So that means that if this angle bisects ABC, then angle 1 and angle 2 are congruent. I guess it doesn't matter the order, which one you put first. And then we want to look at our picture to see if there's any other information that we can get. And I see some vertical angles here, 1 and 3. So we're going to go ahead and say that angle 1 and angle 3 are vertical. And so, definition of vertical angles. And if you wanted to kind of skip a step, that would be okay. We do have a spot for it on this one. But if you wanted to just go ahead and skip step 3 altogether and use that 1 and 3 are congruent by the vertical angles theorem, you could go ahead and do that. As we can see that they're vertical angles up there, so we know they're congruent by that vertical angles theorem. And then lastly is the transitive, using 2 and 4 to help us get 5. Since they are both congruent to 1, they are congruent. Kind of taking the first and the last and putting them together. All these other theorems down here with perpendicular, you already know. If we have perpendicular lines, we have right angles, 4 of them. If we have right angles, then we know all of those angles are congruent to each other. And if we have, again, perpendicular, then we know that they're all congruent kind of pairs next to each other, adjacent angles. 5 and 6, if they are supplementary and we have them being congruent as well, then they would have to be right angles. And going the kind of direction of a linear pair in their right angles, if they're congruent, then they must be right angles if they form a linear pair. So, given we've got perpendicular, then that means that all of them are right angles because perpendicular lines form 4 right angles is our reasoning there. And then definition of complementary, well, that means that angle 1 and angle 2 are complementary. And angles 3 and 4 are complementary. And we are given that 2 is congruent to 3. And so lastly, if they are complementary to the same angle, they are congruent. That is the congruent complements theorem.